Today you're going to learn how to find the area of composite figures. So far you have learned how to find the area of a triangle, a trapezoid, parallelograms. Now it's time to sort of put all of that together and find the area of composite figures. Before we can find the area of a composite figure, we better figure out what a composite figure is, right? A composite figure, and remember, you should be writing down everything that I write down in your notes packet. A composite figure is a figure made of two or more two-dimensional figures. That's what it is. Composite means put together or a mixture. So a composite figure is a figure that's made up of two or more shapes. So let's draw a composite figure below of a rectangle and a right triangle on this graph paper. Okay, yours may not look exactly like mine, but you'll get the idea. So on the graph paper that you have in your notes packet, you should start by drawing a rectangle, and then a triangle. And then what I'm going to do is erase this line in the middle between the two figures, and that's going to be my composite figure. You can see that my composite figure that I drew is composed of the rectangle, which is right here, and then the triangle, which would have been right here. Okay, that's a composite figure. Okay. As you can see in this picture, we have a pool, and we want to try to find the area of the pool. In order to do that, we kind of have to talk about what it is, okay? What two-dimensional figures are used to make the shape of the pool? Well, you can see there's clearly a rectangle here, and then the entrance to the pool where the steps are, what does that look like to you? If you were to kind of look at this in more detail, what does that look like? I'm going to stretch it out a little bit so you can see. It should look like a trapezoid to you. Okay, so this composite figure, this pool, is comprised of, I'm going to write the pool is made of a rectangle and a trapezoid. How could you determine the area of the pool floor? Well, you could separate the shape into the rectangle and the trapezoid and find the area of each and then add them up. So you could find the area of the rectangle, find the area of the trapezoid, and add them up. That would give you the total area of the pool. So let's try to find the area of the composite figure that is shown below. Okay. As you can see, I have drawn a square and a triangle together. We need to find the area of this composite figure. In order to do that, we should do like we did when we talked about the pool. First, we should find the area of the square. Okay, find the area of the square. You should remember that the area of a square is length times width. Okay, if we look here, we have a width of 3 and a length of 3 on our square. So the area is 3 times 3, which equals 9. Okay, we should also find the area of the triangle. The area of the triangle is 1/2 times the base times the height. So our area equals 1/2 times the base, which is 2, and the height, which is 3. Okay, so 1/2 times, let me just squeeze this over a little bit so I have a little bit more room for you guys. 1/2 times 6, which then equals 3. Oops, I didn't mean to do that. So then we would add the sum of the two areas. So we would find the sum of the areas. So our area of the square is 9. The area of the triangle is 3. Our total would be 12 square units. That's how we do that. It's not very hard, is it? Okay. Go ahead and go to your next page. Okay, let's find the area of this composite figure. Okay, we've got a shape here, and it looks to me like it is formed by a couple of different figures. So into what two figures could you divide this shape into? Hopefully that you see that you could divide this into a rectangle and a triangle. Rectangle and triangle. What is the formula to find the area of a rectangle? Hopefully you will remember that always. It's length times width. And what is the area for finding the area, or what is the formula for finding the area of a triangle? Well, we've done enough of that too that you should know it. The area of the triangle is 1/2 times base times height. What are the dimensions of the rectangle? The rectangle dimensions are 15 and 10. So 15 by 10. So 15 by 10. What are the dimensions of the triangle? Okay, the triangle has a base of 5 and a height. Let's see if it shows it here better. The dimensions of the triangle are the height of, it doesn't really show the height, does it? So let's find the area of this. Sorry, I had to pause for just a minute, but I'm back. So anyway, the dimensions of the triangle are 5. It looks like they forgot to put a piece of information in here for us, but the height should be, I'm going to put this in, 4. Okay, so 4. 5 by 4 centimeters. The area of the figure then should be, we have to find the area of a rectangle, area of the rectangle, and the area of the triangle, and then find the sum. So our area of the rectangle is 15 times 10, or 150 centimeters squared. The area of the triangle is 1/2 times base times height, which is 1/2 times 20, or 10 centimeters squared. So our sum is 160 centimeters squared. That's the area of this composite figure. Okay, go ahead and go to your next page, please. Okay, let's find the area of some composite figures. Okay, here we have a shape. Kind of looks like a little building. It's comprised of a rectangle and a triangle, all put together here. So we need to find the area of both. Okay, the area of the rectangle is 6 times 10, which is 60. The area of the triangle is 1/2 times 4 times 4, or 1/2 times 16, which is 8. Okay, the sum of these would end up being 60 inches squared plus 8 inches squared, which equals 68 inches squared. That is not very difficult, is it? It's really pretty easy stuff. As long as you know your formulas, it's really not hard at all. Go ahead and go to Okay, now I want you to do this one on your own. So I want you to really look at it, and I want you to try to solve it on your own. And then when you come back, I want you to press pause, try it on your own, and then come back, and I will help you figure it out. Okay, welcome back. Hopefully you've shown your work and are ready to check your answer. Okay, I'm going to help you to figure out this problem. Hopefully you tried to solve this on your own, and now I'm going to do it for you. In order to solve the area of a composite figure, you need to break it into two figures that you know how to find the area for. So this looks to me like it is a triangle and a rectangle combined. So we could draw lines to help us see the shapes. So if I draw a line like that, then I can see that I have one rectangle right here and one triangle right here. So then we can start to find the area of each of those figures and then add it up. So let's find the area of the rectangle first. Okay, so area of the rectangle is equal to the length times the width. That's pretty easy. Our length is 12 and our width is 4. So this is pretty easy. So we would do 4 times 12, which equals 48 square feet. Okay, so that would be the area of the rectangle. Now to do the triangle, that's also pretty easy. That is 1/2 times the base times the height. Now this one's going to be just a tiny bit trickier because we don't have all of the information. In order to find the base of the triangle, it's this piece right here. Well, we know from here to here is 8, and this total is 12. So that means that the base is 4 feet. Now we also need to find the height, which is going to be right here. If we know that this is 4 feet and the total of this length is 10, that'll mean that this is 6. So our triangle will be 1/2 times 6 times 4. 6 times 4 is 24, and 1/2 times 24 is 12. So our area of our triangle is 12 square feet. Now in order to find the area of both, or the entire composite figure, we need to add 48 plus 12, and we will get 60 square feet. Hopefully that helps you, and you can go on with the next examples. Bye for now. This is another one that I'd like you to try on your own first. So press pause and then find the area of this on your own first, and then I will help you with the solution on the next page. Okay, I just realized, and you will probably realize the same thing, there was one piece of information that should have been on here that I'm going to put in here for you, just to make that a little bit more clear. And then you should still go ahead and solve this on your own. And then when you're ready, press play, and I will solve the rest. Okay, welcome back, and let's go ahead and look at the solution. Okay, on this one, your answer should be, let me go ahead and put this in. Let's find the area of the rectangular square first. That's the easy part. Okay, so if we drew a line like this, we try to fill in the missing pieces first. Okay, this is obviously 7. It's a square. They have right angles. It's a square. 7 times 7 equals 49. Okay, the area of the trapezoid, which is the other figure, trapezoid's a little bit harder, right? It's 1/2 times the height times base 1 plus base 2. Okay, so let's go ahead and fill that in. we know that it's 1/2 times the height, which the height is going to be 3, right? Because 7 plus 3 is 10, so 3. And then base 1 is 7 plus 5. There's 2 bases. You can see here, this is base 1, this is base 2, and this is our height. So now we need to go ahead and calculate that out. 7 plus 5 is 12. 12 times 3 is 36, and 1/2 times 36 equals 18. We need to find our sum now of the rectangle plus the trapezoid. So it would be 49 plus 18 equals 67 meters squared. Good job. Go ahead and go to the next page. The next thing that we're going to learn about is finding the area of overlapping figures. So we have a square and a rectangle that are overlapping. We need to find the area of this. So let's see how to do this. Okay, the first thing that you're going to want to do is find the area of each of the pieces. So the area of the square is the one that we're going to do first. This should be 12 times 12, which is 144 centimeters squared. The area of the rectangle is 12 times 15, which equals 180 centimeters squared. The sum of those two areas is 324, which is 144 plus 180. Okay, now we need to find the overlapping area. The overlapping area, which is right here. This is the overlapping area. We need to find out what that is. Okay, how do you think we're going to do that? Okay, that's pretty difficult to be able to do. You have to look at the piece of information that you have, and you can see that if this piece right here is 8 centimeters and the whole thing is 15 on this rectangle, that means this little piece right here is 7. The other piece that we can see is that this must be 6 right here, because that's half of the 12 that we have, and you can see there's 6 right here. So that means this is also 6. Okay, so the area of this is 7 times 6. 7 times 6, which equals 42. We need to subtract the overlapping area because we don't want to count it twice. So we would take 324 minus 42, and that will equal 282. So the area of the figure is 282 centimeters squared. So now I want you to try one on your own. Go to the next, and you're going to find the area of this overlapping figure. So first thing you want to do is find the area of both rectangles and then subtract the overlapping area, which is right here. I'm just going to write for you overlapping area so you can kind of figure it out. I might help you out with just a little bit here. Do the area of the rectangle first, of rectangle 1, which would be 6 times 8, and then the area of rectangle 2, which should be 7 times 6, and then you're going to want to figure out what the overlapping area is and subtract that, okay? I'm going to let you figure out the rest. Okay, press pause, figure it out, and then come back and check your answer. Okay, welcome back. Your answer should have been 65 feet squared. Okay. If you did not get 65 feet squared, please check with your teacher to figure out what went wrong. Okay. I have a piece of important information for you that we need to remember whenever we do overlapping figures. Okay. It is very important not to forget about the overlapping area. Okay. It's very important not to count it twice. not to count the overlapping area twice when you calculate. When you find the area of overlapping figures. That's the most important thing to remember. Sorry, my writing got a little messy there. Let me erase that and write that one again. Okay, so if you want to know how we figured out the area of that one that you did on your own, if you're not sure how that was done, let's just do that. Okay, so the area of the first rectangle was 6 times 7, which equaled 42. Area of rectangle 2 was 6 times 8, which equals 48. Our overlapping area was, let's see here, that would have been 5 times, and then this would have been looks like it was a square, so it should have been 5 by 5. Oh no, it looks like it was 5 by 6 because there were 2 feet not counted. Oh no, it was 5 by 5. It was 5 by 5, so that equals 25. So we end up with 48 plus 42, which equals 90. And then we subtract the overlapping area, which is 25, and we get 65 feet squared. That's how that happened. Okay? Hopefully that makes sense to you. If you have any questions at all, please make sure you ask for a little bit of extra help or a few more examples. Go ahead and complete the note check before you move on to the practice problems. Bye for now.